Hi everybody. We will start with the first session on creative cognition with Selina Weiss. She was a student assistant at University from 2012 and started to work as a research assistant, pursuing a PhD in the Department of Individual Differences and Psychological Assessments in 2016. She's working on her degree under the supervision of Professor Oliver Willem. The focus of her study is on creativity, where she's contributing to the discussion of how to measure creativity, how to score it, its dimensionality and its nomological. Now, with some colleagues from Germany as Diana Sterberg, Ulrich Truder, Andrea Adelbrandt, Jan Werker, and Oliver Welde from Ulm University, Kansel University, Karl von Jorzowski University. She will talk about the origins of originality, dimensionality, and creativity, and its relation with ability and personality. You have 12 minutes, Selina, it's okay?
Can you hear me or see me or my slides at least? Yeah, I can't see you, that's unfortunate. My flight was cancelled, so yeah, I can't be here. I'm very sorry for that, but thank you for inviting me like that. Yeah, as I was already introduced to, I want to talk today about the dimensionality of creativity and its relations with ability and personality. So now my slides are moving. That's unfortunate. My flight was cancelled, so yeah, I can't be here. I'm very sorry for that, but thank you for inviting me like that. Yeah, as I was already introduced to, I want to talk today about the dimensionality of creativity. Okay. Yeah, so first of all, I want to quickly, you're pretty aware of most of the points, I guess, in the introduction, but I quickly want to introduce you to the structure of divergent thinking and how it is embedded into the nomological net of ability and personality. And I want to introduce you to the study we have conducted in Germany regarding that. So this is the group that is working on the creativity project. So I'm doing, as I was introduced to here, my PhD in that project, and we did a huge collaboration with Ulm University on the left, Kassel University, and University of Oldenburg with Professor Andrea Hildebrandt. And I'm very thankful to work together with that guys. So why are we talking about creativity? Yeah, I'm doing pretty obvious that it's quite important topic in our day's world right now. So we were studying across a variety of studies, also McKinsey studies and all these huge studies in work life that were stressing that creativity is the only ability that makes us human anymore in a computerized world. So the computer can replace the human regarding intelligence, speed, and whatever variables you can think of. But creativity cannot be done by a computer so far. And so this is why it's a very important skill in the work, actually, in the work life. And this is why schools are focusing more and more on creativity. So there will be the creativity measure in the innovative domain in PISA 2021. Yeah, and as you know, it's related with so many important outcomes, like academic performance. It's also related with personality, intelligence, and just values. So, but there is a variety of problems that come along with creativity. So there are a bunch of measures. Some measures are problematic regarding validity and psychometric indexes. And despite there is a quite huge body of literature basically since the 50s, and there are only small amounts of really big multivariate studies. And yeah, if we are thinking about divergent thinking, we are sure running also into kind of scoring problems. We were looking at creativity and we were trying to define creativity for our purpose. So I'm aware there are a lot of definitions, but this is how we define creativity at stake. So we are based on bipartite definition that includes originality of product or idea, and that includes the appropriateness or value of this product or idea. And so we also then were searching for the dimensions that are measured within divergent thinking, and quite super step across dimensions like fluency, so the ability to produce a lot, originality, the ability to produce a very surprising, clever answer. And actually, the originality idea is quite in line with this definition if we just look at the definition like that. And so, but if you look at the literature, you see these two dimensions are highly correlated, and this is why it's discussed if they are even distinguishable, or if the originality score should be even dropped. And doing more research on that, and we also tapped into the discussion about insight. So insight is the real sample of elements to achieve novel and new combinations, so in verbs, for example, measured. And there was a good discussion if that should be or can be a measure of creativity or not at all. So if that is more a convergent thinking measure, or if that can be a divergent. This is the state of the literature basically now. If we are looking at creativity in the non-logical net, so where is it between intelligence and personality, then there is a huge body of literature that is discussing that. So just to pick out a very few here, because you are aware of that literature, is that intelligence was in previous studies moderately or sometimes even only smallly correlated with divergent. And we know that openness was often found to be very highly correlated with divergent thinking, but also other factors like extraversion or a negative correlation between honesty, humility, and divergent thinking. So we know that a huge multivariate study followed this research question that we basically want to compare different scores, test scores of divergent thinking, and want to model that in order to assess the question how is or what is the divergent dimensionality of divergent thinking. And we expect basically, based on this definition of creativity, that we find a specific originality factor that is in fluency, in general fluency, because fluency is that important and they are that hard. So we tested that in study 1, and in study 2 we readdressed study 1 and added a further insight factor, or added insight measures for sure, and then embedded the best fitting model here into the nomological net of established abilities. And we were thinking that we might find, based on the literature, a medium correlation with general intelligence, small positive correlation with openness, even a larger correlation with openness and extroversion, and negative correlation with humility. So these were our expectations. We did this 2 studies together with our colleagues. It was in study 1, 152 participants, in study 2, 298 participants. One was based on a 2-hour lab session and an EEG session, so I won't tell anything about that today. This is doing my colleague Yetwin Kaur. And study 2 was based on a 5-hour lab session and 2-hour sessions at home. So it was quite a test. So this is a quick overview regarding the measures we employed. So we have a variety of creativity measures. I don't know if you can see my mouse here, and they are here on the at least left side of my street. So we have verbal divergent thinking measures, figural divergent thinking measures. Then we have what we called creativity variates. There we had retrieval fluency. We had self-regarding of creativity, and we had insight measures like scrap verbs and anagrams. And we also designed a test for self. We called it the taste test. I won't tell anything about that. And then we had a variety of covariates like vocabulary, working memory, speed, also including typing speed. Then we had fluid intelligence and crystallized intelligence. And we had measures of overclaiming, faking. Then we had hexaco as personality measures, and we were taking genes from all the samples, e.g. one. So these are the measures. I only will talk about the black measures today. The others that are shaded, I won't tap today. But just that you get a picture, bigger picture of the studies. So divergent thinking measures, as I said, employed fluency and originality divergent thinking measures. So this is just a quick overview of example items, as you know what tests we use there. So we use test similar attributes with including items like what is inedible for humans, and then you have to name a lot of things, for example. Same with inventing names, invent a lot of names for an abbreviation. Then as an originality measure, we clearly instructed only to come up with one very creative answer and take time to invent that answer. And here we used names, so they should invent a very creative nickname. I know this is quite a German thing to come up with nicknames, so that maybe not work in other languages that well. And we had another measure combining objects. Here you had to combine two objects to fulfill a particular request, like building stores. And in Insight, I already said that we had a task with anagrams and a task with Scrabble verbs. I know this is quite a German. So what we see here, I'm also turning to the results already, is the dimensionality we found. So we tested, or basically we tested 3 models against each other. So the black part of the model was basically that the model we can deployed in study 1, and all the models, including the gray parts, were tested in study 2. And we found, so the fit indices are not on that slide, but what we found in study 1 is that basically all the measures were fitting quite well the data. And then we looked at study 2, we found that measure 1, so the one-factor solution, was not fitting the data at all, and measure C here was fitting the data quite well. So we found that we have an overarching factor that is explaining fluency, or is capturing variance for fluency, and then we have 2 nested factors that are just loading on the originality tags or on the insight tags beforehand. So that was for us quite an interesting finding, that this model worked out quite well. And we hoped at that, and we expected that it did. And so in the end, we embedded model C into the nomological net that you can see here. And so you now see here model C on the bottom of the slide. And you see again the fluency, the general factor, originality, and insight. And we now see the relations with all other variables. So we have on the right side, we have personality. We only modeled the personality factor into the expected relations, and on the upper side we have intelligence. So there we have a G factor that includes mental speed, fluid intelligence, crystallized intelligence, and working memory capacity. And now the relations are quite interesting. So some are exactly as expected, like there is a moderate relation between general intelligence and fluency, and also between crystallized intelligence and fluency. The dotted lines here are all not significant, just to tell you that. And so insight was also predicted by general intelligence here, that is as you would expect too. What is interesting is that originality was not predicted by either personality or intelligence. So openness basically was moderated here via GC, but there is no direct path going to originality. So we discussed in our group, that finding a lot, and we were looking at this originality factor more closely and still are doing, and found that this factor is having significant variance, but the variance in this factor is not quite broad. So probably this is due to that because there are only two measures or two tasks to test tackling originality. Yeah, I found these are quite interesting results regarding the dimensionality and the embedding dimensionality of divergent thinking in the nomological net. And so now I will close my talk with a short discussion. So summarizing the results, I told you that we have overarching fluency factor that basically tells us that fluency is an important component of that task, all of these tasks, and fluency is basically in the end a precondition for originality and insight, at least as we measured it. Originality, interestingly, was not predicted by any of the covariates. It has had significant factor variance, but very low reliability. So the factor omega was only 0.20, just quite low. So we think that with a broader assessment in first studies, we can basically get better results regarding the factor variance. Insight showed strong systematic individual differences beyond fluency, and this factor had good reliability and all that, but also aware that it needs more studies tackling this insight factor and its nature. So in the end, we said that while measuring divergent thinking, including factors like fluency, originality, and insight, more than just a lower level factor of intelligence. So the relations with intelligence are there, but not surprisingly high or anything like that. And it's more than personality. So it is creativity. There is creativity remaining or left. And so for further research, we would suggest that broader measurement of originality can help us to understand the nature of originality better in the future. And that should be maybe also complemented by other scoring methods, like there are computerized scoring efforts to discuss and so on. So this is my talk. Thank you so much for listening. I hope you could hear me. We are also just have submitted that paper, and we are hoping that these results are published soon or self-published. And I'm very happy to hear your questions. Thank you so much.
Thank you, Selina. We have no time for questions. Sorry.
Oh, sorry.
Maybe by email if you want to ask her.
Absolutely, you can email me.
Next presenter, please.
So I will switch off. Yes. Bye.
We will know her. Bo Christensen is Professor Emeritus in Creative Cognition at Copenhagen Business School. A cognitive psychologist by training, his works include ethnographic studies on design practice and experimental studies on design cognition. His theoretical focus is on creativity cognitive processes as analogy, simulation, and incubation. And now he will present with Morten Friis Oliveris from Copenhagen Business School 2 in Denmark, the cognitive size of ideas. His works include ethnographic studies on design practice and experimental studies on design cognition. His theoretical focus is on creativity cognitive processes as analogy, simulation, and incubation.
Thank you.
And now he will present
Hello all. I'm Bo Christensen of Copenhagen Business School, and I'll be using my allotted 10 minutes to talk about sticky notes and how to use sticky notes as a window to examine creative cognition. Just a few pointers before I get started. This work was done together with Morten Friis-Olivarius, who's there. So all the tough questions should go to Morten in the break. In order to keep time, I'll stick to my notes a little bit. Sorry for that, but 10 minutes is a short time. I'd also like to mention that it's, of course, usual to mention your funders. This research was supported by the Strategic Danish Research Council. But I would also like to highlight that this research is in no way funded by any sticky note producer. Just if you're curious. I'll be saying many positive things about post-it notes, but they did not support our research. Final point is that I'll be talking about how to use post-it notes as a window into creative cognition. Tomorrow morning we'll be hearing Matthias Benedict talking about how to use neuroscience as a window into creative cognition. So this is a nice contrast. This is the very low-tech end of how to study creative cognition. And you'll be getting the high-tech one tomorrow. Okay. Specifically, now I'll be talking about how to use sticky notes as a window into creative ideation and idea development. I'll be illustrating by trying to cover one sample research question that can be informed by sticky notes, which is, what is the cognitive size of ideas during initial ideation? Nice contrast. This is the very low-tech end of how to study creative cognition. So, sticky notes abound in creative practice and as support tools in creativity techniques. Some of the techniques commonly using sticky notes are at the top here. At the bottom picture, you have an in-field study on design cognition, where we traced a creative design team in a European car manufacturer over a period of 4 months, documenting their extensive sticky note usage to support a variety of aspects of creativity. Sticky notes abound in creative. Perhaps there's a reason why sticky notes are so intimately tied to creative activity. For the present studies, we've used sticky notes as a window into creative cognitive processes in idea development by exploiting the fact that they're used to externalize and capture ideas in creative work. In creativity production, sticky notes have the attractive quality that it is subjectively easy to mentally parse ideation processes into distinct idea chunks. That is, to write a single idea on each note. This has the advantage that the subjects themselves segment complex creative processes into, for them, subjectively meaningful units of information. And this actually allows for the study of how ideas come into existence. And it further allows for research questions such as how are ideas generated, how are they discarded, and how are they further progressed in the problem space. How do categories of ideas get formed? You can actually study that using sticky notes. How do such categories develop structure and turn into working mental models or into final ideas? By studying the content of sticky notes from brainstorming sessions, as well as the temporal dynamics in their production, we aim to get a better understanding of what ideas actually are from a cognitive standpoint, and how they evolve over time. And how are they further progressed in the problem space? How do categories of ideas get formed? You can actually study that using sticky notes. We cannot cover all this in 10 minutes, so I'll stick here to illustrate sticky note analysis with a sample research question. What is the cognitive size of ideas during initial ideation? Both popular saying and theoretical conceptions will have us believe that ideas may vary in size and be either big or small. The theoretical distinction between small versus big pertain primarily to the level of impact that the final idea has on the domain that it tries to advance. However, ideas may also have a cognitive size at the moment of initial production. Perhaps well-known cognitive limitations, such as working memory capacity, sets boundaries for the cognitive size of initial ideas. The theoretical background for this research question is listed here, and it involves that classical theories of idea generation, they have mainly implicated associative memory in how ideas arise initially. But there's a growing consensus building that no single cognitive subsystem alone can explain creative productivity. Contemporary work also highlights the central importance of working memory in the production of initial ideas. And the search for ideas in associative memory, or SEAM model, assumes that idea generation is a repeated search operating in two stages. First, a stage of knowledge activation, implicating long-term memory or associative memory, followed by a stage of active and mentally taxing idea production in working memory with a limited capacity. Given the limited capacity of working memory, SEAM predicts that each initial idea produced should be of a very limited complexity, mainly altering features of a single, what they term, image, or combining a single image with new elements. The SEAM model further explicitly stipulates that ideas are to be thought of as distinct from associations. While associations are connections between or within images, they may not require much working memory capacity to retrieve and pre-recall. Ideas, on the other hand, are the working memory taxing active search and manipulation of ideas under a set of task constraints. So we tested these predictions in two studies. The first one, using sticky notes, we asked some students to participate in a facilitated stick-em-up group brainstorming. They were working with the problem statement of coming up with a new business model for an existing credit card company as part of a course on business models. They spent 20 minutes ideating with standard brainstorming instructions, and they worked with two different sizes of sticky notes, a smaller one, a regular 3x3 inch, and a slightly larger, also very standard, 3x5 inch counterbalance for ordering. I should just note here that the problem statement here is a very complex one, and that will actually be important later in the talk. The process was videotaped. The 867 sticky notes were generated, and they were transcribed and coded for content. And the results here, for those of you familiar with ideation, will perhaps not be too surprising. The ideas generated were exceedingly small. The most frequent idea size that was produced was a single word, typically a noun, and on average the sticky notes contained a mere 3.8 words on each sticky note. Compared to the complex problem statement that we saw before, each idea contained very limited information pertaining mainly to aspects of the overall problem statement. To rule out that the limited amount of information was not merely due to the small form factor of the sticky note itself, we compared the two sizes of stickies for amount of information and for content, and the larger sticky notes did not differ in any respect from the smaller ones, indicating that the results are not merely due to the size of the sticky note itself. So we then went on to explore a variety of things. I cannot cover all that in detail here, but there's a paper behind I will mention in the end. We then explored the linguistic structure of the ideas that were generated. What I would like to highlight is that while the most common ideas produced contained a single word, other ideas would combine two concepts or manipulate single concepts through verb action. A few would in addition contain simulation elements with words indicating causality between constructs. So, in conclusion from study 1, in support of the predictions of the SEAM model, it seems that initial ideas for a complex problem is of limited size. Assuming that sticky note content in idea generation mirrors creative cognitive structures, initial cognitive ideas appear to be quite small, about 3 to 4 words on average, covering only one, usually, or sometimes two main constructs that are only sometimes manipulated or actively connected. While the results suggest the implication of working memory capacity limitations at the moment of ideation, they also open the question of whether ideational production then differs from mere associations at all, as theorized by the SEAM model. So we tested this more directly in study 2. About 3 to 4 words. We had 186 subjects perform the alternative uses task, either with standard alternative uses instructions on generating alternative uses for common items, such as a brick, or on a revised set of instructions asking them instead to list associations of a brick. In terms of the results, several things are worth pointing out here. Again, the ideas produced with the standard alternative uses instructions contained approximately 3 words on average. whereas associations produce just over a single word. For both types of instructions, the most frequent response category was a single word, but the distribution differed, as illustrated in the histogram, with almost all response being single word for associations, while alternative uses instructions showed more variation. As also suggested by study 1, the structure of an alternative uses response differ from mere associations, with ideas more frequently containing verbs, adverbs, and more than one noun. This indicates manipulations of concepts and conceptual combinations. In terms of the results, several things are worth pointing out. So, again, the ideas produced. What is the overall conclusion here? Our results seem to support the SEER model, indicating that a central engine in ideational production is capable of bursting out multiple small, disparate ideas in the form of simple image manipulations or small-scale conceptual combinations. If we consider each idea, they then seem to arrive in a very limited size. And this again is in the context of a very complex problem statement. With the externalized output covering about 3 to 4 words on average, covering only fragments of any complex problem at rest, but simultaneously significantly different from associations. The results suggest that initial ideas are beyond associations despite their small size. They do involve the working memory taxing application of mental operators, manipulating the concept in question. They sometimes combine concepts and sometimes involve mental simulations of causal relations. While these results tell us a little bit about the nature of initial ideas when they arrive, they do not tell us very much about how small ideas eventually grow up to become fully fledged big ideas through selection, through categorization, and through the building up of mental structures. We're currently finalizing an edited book addressing this and other creativity issues using sticky notes. It's coming out on academic press later this year on James Kaufman's Creativity book series. And what I've covered in this talk is about a third of chapter 3. So read the book if you find this interesting. Thank you. We're currently finalizing an edited book addressing this and other. While these results tell us a little bit about the nature of initial ideas, it's coming out on academic press. They do not tell us very much about how small ideas eventually grow up. Book series to become fully fledged. What I've covered in this talk is through selection.
Hi, Wendy Ross, Kingston University, London. My question is about the interaction you might have found between working memory and the offloading of the working memory by using the post-it notes, because I noticed that you didn't have anybody not using post-it notes. And obviously there's a reasonable amount of evidence that the post-its will allow you to sort of increase the flow, increase the frequency. Did you notice that? Did that come into any of the...
Yeah, I mean, we did not have a control here for not using post-its. That was not really considered the main idea. This was an exploratory study trying to study what is the size of ideas, basically. In this case, I would say post-it notes in general tend to increase the number of ideas compared to a brainstorming session where you have someone noting down for you, right? That's the usual productivity loss that has been well documented in the literature. So I would say post-it notes in general increase the level of productivity in brainstorming sessions. But I mean, that was not the main point here, so we did not include that as a control. The size of ideas, basically. In this case, I would say post-it notes in general tend to increase the number of ideas compared to a brainstorming session where you have someone...
Pat again, North Central University. Wanted to know, when you did this testing, did you do it in different areas such as Africa or other in multicultural factors? I was wondering if it changed at all.
I'm a cognitive psychologist, so we tend to not care about those things, I'm afraid. So this is a North European type of sample with university students, basically. Very white, very grad student-like. Sorry about that.
Areas such as Africa or other in multicultural factors. I was wondering if it...
Okay. Yeah, do come talk to us in the break, Morten. Thank you. North European...
Now we will finish this first session by Chiara Rastelli He is a research assistant at the Department of Psychology and Cognitive Science under the supervision of Professor Chiara Rastelli in University of Trento. She explores mechanisms underlying the creative thinking in cognitive and computational terms, with a focus on individual differences. To achieve this, she uses computational network science method to represent and analyze semantic memory structure. And she will present now a work with Chiara Rastelli about semantic networks predict difference in fluid intelligence and different thinking among children. Underlying the creative thinking in cognitive and computational terms, with a focus on individual differences. First session by Chiara Rastelli is a research assistant at the Department of Psychology and Cognitive Science under the supervision of Professor Chiara Rastelli in University of Trento. She explores mechanisms underlying the creative thinking in cognitive and computational terms, with a focus on individual differences. To achieve this, she uses computational network science method to represent and analyze semantic memory structure. And she will present now a work with Chiara Rastelli about semantic networks predict difference.
Vedono anche gli altri, ma anche vedremo anche.
Hi everyone, I'm glad to be in here. So, creativity is a prominent cognitive process allowing human development in everyday life. Creative cognition allows to provide adaptive responses following a principle of economy, and thus minimizing the quantity of information. According to the standard definition of creativity, I'm glad to be in here. Creativity is conceived as the process whereby something novel and appropriate is generated. In fact, generating creative ideas induce reconstructing of representation, which may involve re-encoding the problem, identifying and implementing cognitive strategies, practicing control over attention and thoughts, and inhibiting inappropriate ideas. Beyond the importance of divergent thinking abilities, a growing amount of research has been considering fluid intelligence as one of the greater predictors in differentiating creative solutions. Although we gain a lot in terms of knowledge about creative cognition, the role in fluid intelligence in creativity remain controversial. So, what is creativity? What makes some people more creative than others? Let us consider the brain as a search space, also known as semantic memory space, a roadmap of concepts with paths in between, connecting the concepts that are related to each other. How many concepts are represented in the search space depends on knowledge and experience, and how each concept relates to other concepts depends on education, environment, and personality. So, semantic memory plays a role in the creative process, either as an integral component or as the basis upon which executive functions operates on. So, current theories of creativity of creativity relies on two accounts. The top-down account of creativity states that the creative thought is a top-down process that taps individual differences in the ability to control over attention and cognition. The bottom-up process, on the other hand, results from the individual differences in the structure of semantic memory. Thus, creative individuals seem to have a richer and more flexible associative network than less creative individuals. Top-down process that taps individual. And we arrive to network science and small word network. Network science methods have recently been applied and allowing us to quantify the role of semantic memory structure in creativity at a cognitive level. One of the models developed in network science, mostly used to examine complex systems, is the small word network by Wolstenstrograd, presented in 1998. And the main feature of the small word network includes the clustering coefficients, which is the measure of the probability that two nodes close to a single node will be themselves close. The average length of the shortest path, ASPL, which is the quantity on average of the shortest path between two pairs of nodes. So, for example, if we start here, we have 1, 2, 3, 4 nodes. So we calculate the average between all two pairs of nodes. And then we have the Q index, quindi, so the modularity index, which allows to quantify how much a network is divided into subgroups. And finally, the small word network measures can be considered as an index of network's efficiency or network complexity, and thus is characterized by high local connectivity, higher clustering coefficient, and also by short global distances between nodes with lower ASPL. So in this way, small word networks allows efficient diffusion of activation and information retrieval. Can be considered as an index of. So, particularly in this study, we investigated how fluid intelligence and divergent thinking of a typical children population are related to the structure of the semantic memory from a network science perspective. ASPL. So, recent studies suggest that participants with higher performance in DT and fluid intelligence tests move from one category to another more often. And therefore, the more the switching during the test, the more lexical network will be structured and modular. However, according to the results obtained in other research concerning the divergent thinking network, we would expect that its lexical structure will be less modular and more flexible. Therefore, we could predict that the high GEF groups network will be more structured, showing a longer ASPL and higher Q, so modularity, and low as compared to the low GF groups. And this will account for the top-down account of creativity. In the other hand, the high divergent thinking network will be less structured with a shorter ASPL and modularity and more flexible, so with higher small wordness compared to the low divergent thinking group. And low. So this is the preliminary results that I will show you today. We have a pool of 54 participants which took part in the research. All were native Italian with at least one parent Italian. And 93% of participants were 10 years old and 55% were male. As you can see, measurements were collected at school. That I will show you today. Regarding the measurements, we assessed the vocabulary knowledge and written word per minute to avoid any confounders from the results, the confounders which rely to language skills. And then we used the word semantic fluency test to assess lexical ability, and we used this kind of test to construct the networks. We use this test according to the standard procedure, so participants had 1 minute to generate as many animal category members they could think of. We use, moreover, 2 other tests to construct the groups. One of those is the standard progressive matrices from Raven, which assess the fluid intelligence and is a measure of inductive reasoning. The test is composed of 60 items divided into 5 series and requires to complete a series of figures with the missing one. The alternative use task from Guilford was used to evaluate the ability to generate multiple alternatives and solutions, and participants were asked to generate as many unusual uses for the word brick in 3 minutes. Regarding the scores, we score fluency, which is the total number of ideas reported, and flexibility, which is the measure of the switching from category solution. Moreover, we rate with the Sylvia in 2008 list guideline based on 3 variables, 3 aspects of answer: uncommon, remote, and clever, according to Guilford notions of creativity. We averaged everything, so the fluency, the flexibility, and the creativity index, to have the final index of divergent thinking. In 2008, in order to include all the participants in the sample, we divided them into 2 groups, low versus high, based on the median of either DT and GF score. While the 2 groups differed significantly as the 2 independent variables, they did not differ significantly in age and the other language variables, so the written word per minute and the vocabulary knowledge. We divided them into 2 groups, low versus high. This is an overview on the network construction. First, on the left, we have the row matrix with all the subject as a row and all the answer, the response, as a column. As you can see, all the cell has got the answer, the responses. Data from the semantic fluency test were analyzed, as we said already, and implementing using a recently developed network science approach from Kenneth. In order to analyze this data, we converted each group into this data matrix on the right, which contains in the row all subjects and in the column all the unique words generated by each group. And implementing using a recently developed network science approach. Thus, a word correlation matrix between all pairs of words were generated using the Pearson correlation, as you can see from the image. We use, moreover, the filter. We filtering and render planar the matrix. So. We use the planar maximally filter graph, PMFG, in R, and to create in output the unweighted and undirected network. Okay, this is example of the network, which has the animal category member as node and the word correlation that is the edges, so the tendency of the sample to generate a word B given that a word A is generated. To statistically analyze our network, we use partial network bootstrap analysis. This is an example of how they work. And those are the results of the network that reveal differences between levels, low versus high, of this is fluid intelligence. So particularly the high GF group is more structured, showing lower ASPL and higher modularity and almost similar small wordness. On the other hand, low divergent thinking networks appear to be more spread out and more flatter, and the high DT networks and the high DT network so is less structured and more small-worded, so more efficient, more flexible. Taken together, the results confirm that even in the developmental population, different levels of GF and DT are associated to different types of organization of the animal category. We want to highlight the final results, so a high level of fluid intelligence corresponds to a more structured lexical network with respect to low levels, and high levels of DT affects the flexible structure of the lexical network as compared to the low DT abilities. Our results corroborate the implementation of network science as a method to study creativity and fluid intelligence in the developmental population, clarifying the role of bottom-up and top-down processes in linguistic creative cognition. Thank you for the attention. Our results, implementation of network science to study creativity and fluid intelligence, clarifying the role of bottom-up.
Hi, this is Matthias Benedek from University of Graz. Very interesting study. Just a quick question: was the number of nodes equal between all the groups? Because the number of nodes
Sure.
is a factor that will influence all the network measures then?
Sure. First of all, thank you for the question. It's an honor. And well, the DT network, in the DT network there are more unique words, so there are 67 nodes, and the Fluid Intelligence Network had 54 nodes, so there are less nodes compared to the Divergent thinking. First of all, thank you.
Okay, so because number of nodes will affect these measures, and could be interesting to control for the number of nodes in your analysis, maybe.
Yes, sure. But I don't compare the GF with the DT. I compare internally the low and high GF and the low and high DT. So I leave the numbers of nodes as they are. But thank you for the suggestion.
Thank you very much to all speakers and to all of you. We have a coffee break until 11:30.